Greetings, class. Welcome to the sixth and final web tutorial for our stoichiometry unit. This tutorial is going to be on the limiting reactant. So this is a fairly recent topic that we've covered, so hopefully it's still fresh in your mind, but I wanted to create a tutorial video just for this, just for those of you that might not have been able to grasp it fully in class. So the limiting reactant, as the name suggests, it's going to limit something. For us in our class, it limits how many reactions are going to be able to take place. So it's going to limit the amount of product formed by any reaction that we're looking at. So we used the example in class. We did the demo where we lit the candle. So we have our candle, and we lit it, and then we talked about what's going to happen. So here we have our lit candle. Bear with me with the drawing. And we have two options, because remember, the candle is made out of paraffin. It's a hydrocarbon. So when it burns in the presence of oxygen. So we have paraffin, which is C25H52. That's going to burn in the presence of oxygen, and as combustion reactions always do with a hydrocarbon, they produce carbon dioxide and water. So our two reactants in this case are paraffin, the candle, and oxygen, our fuel source for our flame. And we ask if the candle's sitting on the lab station, which are we going to run out of first? Are we going to run out of the candle, or are we going to run out of oxygen? And we answered, well, hopefully it's the candle, because otherwise everyone in the room would end up suffocating because there's no more oxygen because we ran out of it. So the limiting reactant is going to limit how much product is made, because as soon as we run out of one of our reactants, whether it be this or our oxygen, we stop making our products. The reaction stops. Now we were able to change the scenario just a little bit. We were able to put a beaker over our candle, and that now then changed our environment around. We were able to limit the amount of oxygen, so this became the limiting reactant. As soon as we ran out of oxygen, we all saw what happened. The candle went out, so we were able to actually get our candle to go out. The reaction stopped because we ran out of one of our two reactants. We were also able to see this. We talked about making cookies, and we found the recipe, and then how many cookies we can make depending on a certain amount of recipe. And we're going to look at a problem involving a chemical equation for the rest of this tutorial. So our problem is as follows. We have aluminum reacting with sulfur to produce aluminum sulfide. So as in any stoichiometry problem, the first thing I always need to do is to write and balance a chemical equation. So aluminum, that's going to be symbol Al. That's going to react with sulfur, and that's going to produce aluminum sulfide. So aluminum, if we look on the periodic table, is a metal, so we're dealing with an ionic compound, so we're going to be dealing with oxidation numbers. So our charge, so aluminum is a +3. Sulfur, which is where sulfide comes from, which is in the ion name for it, is a -2. So when we crisscross, we're going to get Al2S3. In order to balance, I have 2 aluminum on this side. I'm going to change my coefficient in front of this aluminum to a 2. I have 3 sulfur, so I'm going to change my coefficient to a 3. And now we are balanced. So in limiting reactant problems, we are given 2 starting values, one for each of my reactants. So in this case, I have 6 moles of aluminum, so that's my first given information, and we are going to do a conversion with that. And we also have 6 moles of sulfur. And we're going to do a conversion with this one as well. So all we really need to do is we need to compare amounts of product formed, in this case aluminum sulfide. So I need ratios of my two reactants to my product in order to compare. So my first problem here, I need a ratio between aluminum and aluminum sulfide. So that's going to be 2 moles of aluminum. That allows moles of aluminum to cancel out here. So moles of aluminum cancel, moles of aluminum cancel. And then I'm solving for my product in this case, and so that's 1 mole of aluminum sulfide, Al2S3. So like any stoichiometry conversions, we're going to multiply across the top, so 6 times 1, divide by the bottom, so 2. So 6 divided by 2, that means that if aluminum was the limiting reactant, I would get 3 moles of aluminum sulfide, Al2S3, before my reaction stopped. Because remember, once we run out of a reactant, our reaction stops. So this is one possibility. We need to check our other reactant, see if it is going to give us anything different. So now I'm going to look at sulfur, and we're going to solve to say that sulfur, let's see what sulfur would give us. So my ratio between aluminum sulfide and sulfur is 3 moles of aluminum sulfide, of sulfur. So let's change that around. So 3 moles of sulfur. I got that value from this right here. 3 moles of sulfur, that's what my equation tells me, are going to make 1 mole of aluminum sulfide. So 1 mole of aluminum sulfide, Al2S3. So we're going to solve just like we did last time. 6 times 1, divide by 3. So 6 divided by 3 gives me 2 moles of aluminum sulfide. So these are our two values that we solved independently of one another. Now I have my questions that I need to ask. First I need to ask is which value of my product is less. So look here, it's very easy in this one. 2 moles of aluminum sulfide, that's less. And our reasoning says that our limiting reactant always produces the least amount of product. So here's my least amount of product. So my limiting reactant is whatever reactant or starting material that gave me this amount. So I'm going to go back to the beginning of my conversion, and I started with sulfur. So sulfur is going to be my limiting reactant. It gives me less product. Now I need to determine my excess reactant. In the case of a problem where we only have 2 reactants, 2 pieces of starting substances, the other compound, in this case aluminum, is going to be my excess reactant. So because sulfur gave me less product, it's my limiting reactant. I'm going to have a little bit of aluminum left over, because if I used all my aluminum, I would have gotten actually 3 moles instead. So aluminum is my excess reactant for this case. Now this type of problem is fairly easy because I only have one product that I'm solving for, so it's easy to figure out what to choose here. But recall back to what we said in class. I'm just going to write one more example up here so that we can see what's going on. So let's say I have a reaction of aluminum and iron 3 oxide, and they're going to go through a single displacement reaction to make aluminum oxide and iron metal. And I'm just going to balance really quickly so we have that. So here's an equation, and say I was given some value of aluminum and some value of my iron 3 oxide, this Fe2O3, and I wanted to figure out which is limiting. This equation is a little bit different than the last one because I have 2 products that I can choose between. Remember, it doesn't matter which product you choose, just pick the same one each time. So I say let's pick this one, and I'm going to ignore the iron completely. I don't even care about it. I want to focus just on this and do my conversions with this alone. So let's just make up some values really quickly. Let's say I have 3 moles of aluminum and 3 moles of my iron 3 oxide, or more commonly known as rust. So I'm going to find a ratio between my starting information, my aluminum, and the product that I chose, Al2O3. So that's 2 moles of aluminum for every 1 mole of aluminum oxide. So I'm going to solve 3 times 1 divided by 2 gives me 1.5 moles of aluminum oxide. I'm going to solve my second conversion. So I have, in this case, I need a ratio between moles of iron 3 oxide and aluminum oxide. So I'm going to look at my equation. My coefficient in front of iron 3 oxide is 1, so 1 mole of iron 3 oxide reacting with reacting to form 1 mole of aluminum oxide. And then I'm going to solve 3 times 1 divided by 1 gives me 3 moles of aluminum oxide. So again, just like last time, I'm going to compare values. This is my least amount of product. So I'm going to look back to the beginning of my equation to see which reactant I started with, that is aluminum. So aluminum would be my limiting reactant for this, and because of that, that's going to make my iron 3 oxide by nature my excess reactant. Hopefully this helps. Expect to see a couple problems on your test like this, but not too much. If you have any questions, as always, I am available before and after school, during guided study, and during class. Again, this was the limiting reactant web tutorial. This is the last video for the stoichiometry web tutorials. If these ended up being helpful to you, please let me know. I would like to know if this was a good use of my time. Hopefully these were able to guide you in your problem solving, and I would like to know if they helped. So just let me know.